thanks to 3dprint.com. And today we're going to be talking about, well, Arkema. And Arkema has just released a new Pebax Rnew. So this is basically it's a lightweight, very high energy return powder bed fusion material made out of Paybox. So Paybox PEBAX is a block of polymer composite, essentially, of harder polyamide blocks and soft polyether blocks combined together in a certain way. So that means that it turns into kind of to a certain extent, designable at the kind of like mass production Arkema level material that is a rival to polypropylene TPU kind of materials. And it's lightweight, often lighter weight than TPU. It's a long-lasting, very high continuous energy return, kind of continuous elasticity over a long time. TPU in some cases might be tougher, but typically if you want something really thin and lightweight and kind of like a more midsole type application, then this Paybox material is really quite interesting. The other thing is that part of it is made out of like the same chemistry that is the Rilsan PA11. So that's made out of a non-food source castor oil or castor bean based material. Now, it's not clear how much is in this and how much you can get at the moment, but typically you could get maybe something like 70% or sometimes up to 90% of the material comes from renewables. So we know that the Rilsan PA11 material, which is also a powder bed fusion material, is quite popular with designers, with consumer-facing companies. Companies like to tout their green credentials, and in this case, for PA11, they can just say, okay, wait, we can take a PA12, PA11, made from an oil source material, or we can opt for this castor bean source thing, and then we have a green claim to lay at the feet of our consumers. And in this case, the good part is that a lot of times they don't have to really sacrifice a lot on quality, or they don't have to at all sacrifice on quality depending on the application. On the one hand, and on the other hand, what's also really super good is that they don't they don't really have to change a lot of process steps or really qualify a new material or anything like that. So it's been really quite successful. Now maybe then Arkema can repeat the success in these kind of more flexible materials. For now, the materials available from Erpro, which is an Arkema partner. It's the company that prints 1 million eyeliner sticks per month. It's French, and they do a lot of mass manufacturing, especially in France, using powder bed fusion. Later on, it's going to be available on the Easy3D platform, which is Arkema's kind of quoting platform. And presumably we'll be able to buy it, but it's interesting to me they go to market first with Erpro, then they're Easy3D, and then they're only talking about like maybe people buying the material. Does this mean that Arkema is moving more into kind of a parts? Because of course it would be amazing for them to sell parts instead of just material. And then in that case, why don't they just buy Erpro? Why don't they just buy Erpro and then make finished goods out of their materials? And that would really be a leap. Victrex does this for implants. And maybe Arkema should do this for a lot of other stuff. So that's a logical conclusion out of this. But the other second thing is that, okay, now we've got a potentially sustainable material that we can use for shoes. Is that going to be advantageous for brands? Now, we know a lot of people are working with vat polymerization, carbon, and other materials. These vat polymerization materials, these are not recyclable in any meaningful way. So maybe for these guys, especially, the Arkema material from a green material, right, that can also is much easier to recycle. Maybe that could be a real claim, especially for companies like Nike, which have been kind of like sitting on the fence in the 3D printing game as compared to the activities of other companies, especially Adidas. So, I think this is interesting. Other companies like Nike, Scarpa, other companies already use Paybox for like a midsole, insole, or a midsole kind of or other kind of hardened shoe material. So, maybe we really see that now powder bed fusion has more to bring to the market than just TPU and polypropylene, and really could grow. So I think that's a very exciting thing. Next thing is from Voxeljet. Voxeljet has released a cold inorganic binding or cold IOB 3D printing technology. This is essentially an evolution above their existing binder jet kind of intermediate technology. that is used to make sand cores, casting for casting engines and other large parts for ships and stuff like that. And in this case, the cold inorganic binding technology essentially means that they don't need an industrial microwave um, to cure the material. Now, the advantage of this is that you don't have to buy an industrial microwave, right? The other advantage is that it may actually speed up the process time a little bit and reduce emissions, because these emissions aren't the the part essentially air dries by itself. Um, Generally, this technology can be applied to all the existing voxeljet platforms. So people have a VX1000 or whatever can just use this. So this is a great improvement. It might reduce emissions, might reduce harmful emissions for staff. So it's a great improvement for kind of foundry operations that really very well may lead to car makers like BMW and stuff like that using the technology more and more. And I think it's interesting that people are improving this kind of binder jet type of processes. The next thing is a vision, and this is a vision of Urban Reef. Now, we've had a ton of 3D printing stuff going on about kind of like furniture for in the city, 3D printed planters, that kind of thing. And we've had a ton of stuff going on in reefs. People want to 3D print reefs or print coastal reefs and that kind of things. And these guys have essentially combined this. I think it's wonderful, actually, into a wonderful vision of the urban reef. Now, this is it's a wonderful idea. It's essentially a wonderful idea. So the idea is that they say, look, there's a bunch of materials that can absorb water, absorb nutrients, and that can really engender plant growth, can really make plants grow, but in a more kind of interspersed way with the city. Right? Kind of like it happens now. If you see like an old building collapse or an old factory somewhere collapse, then the plant life fights through it essentially and overtakes it gradually. If you see, sometimes you see some weeds coming up between some concrete tiles. Now, these guys are essentially saying, look, we should have a vision of 3D printing structures that will really enable plant and animal life to grow in the city in a much more kind of stable and new way. So rather than have a park or a planter, this will mean more of an interspersed life. And it's really akin to kind of a reef, right? Where you have this structure, it could be an artificial structure that comes down and in somewhere, and it creates this whole ecosystem, right? I'm always thinking, when I think of this, I think of a whale fall. A whale fall is what happens at 1,000 meters below the ocean, right? There's very little life there, right? Well, there's actually teeming with life, but it's really, really very, very interspersed. It's very, very far apart, right? This life. Now, if a whale dies and his body falls 1,000 meters below the surface and rests 1,000, 1,500, 2,000 meters. What happens there is there's this explosion of life around this whale carcass, because there's nothing there. There's nothing in terms of like shade or structure or nutrients or a place to congregate, or a place to congregate that then also causes other species to congregate, which means that it's it turns this empty area where nothing is happening turns into like a buffet for everyone. That just essentially doesn't happen. Unless, like, you get this whale fall, this whale dying and its body coming to rest at this place. So I think of this as a kind of vision that these guys want to do for the city. I think it's an absolutely wonderful idea. It's done, and these guys are looking at river dredge, so the stuff that's dredged up a river to keep canals and things clean. Seashells, clay, mycelium, kind of stuff where there's been a lot of research on that already. They're called Pierre, Oskam, Max Latour, and I think they're really onto something. I think this is a really wonderful idea. I think it's, on the one hand, completely obvious, but to work out the details where it's acceptable to city planners will require a little bit of work. So that's really quite good. Maybe they could use 3D printers from XtreeE. So XtreeE is a French company, and they've just added 3 partners to their network, bringing it to 12 systems or 12 partners worldwide. Now, what these guys are doing is an absolutely fantastic go-to-market. You've probably noticed that there's a lot of money pouring into concrete 3D printing and 3D printing for buildings. And these guys have basically come up with what I think is a much, much better way to approach the market. They're coming up with this kind of multi-local ecosystem. Now, the idea is you can become a local partner by buying a system. You can become their partner in New Zealand or the Southern Island of New Zealand or wherever, right? And then you will then be plugged into their printing as a service platform. So they could get an order at one point. Somebody could order stairs or whatever, and it could go to the nearest system. So compared to buying another system, Cobalt or whomever, with XtreeE, you might actually get revenue inside. You might actually get a steady stream of leads if they do their marketing correct. So I think that's wonderful already. And their idea on top of this is even smarter. I think this is brilliant. They basically have a bunch of digital tools they hope to essentially develop, right, to help the people produce parts. So they have a library of approved things. So they could then, figure out how to do a planter or one of these urban reef things or a slope stairs or whatever. They can figure out all of the loads and all of the different sizes this thing can be, and they can figure out all the qualifications, all the regular kind of like the safety things, and they can then make that available, that model available for download. So you could have that model and print it out in Japan or print it out in China or whoever. And there's also training and how to do the parametric design yourself, how to work with the robot. There's design tools and all this kind of stuff, and an online analysis to help you kind of design things and test them out. I think this is fantastic. Not only does it mean that XtreeE will get more revenue because it'll be able to charge people for access to the platform, it also means that their partners could get quicker revenue, or could more quickly be able to utilize their machines and print things. If I have to buy a machine from someone else, it might take me 1 or 2 months to get used to this system and to print something. Well, maybe with XtreeE, I can get the training and the onboarding and all this stuff, and it happens much, much faster. So that to me is I think it's a really, really brilliant idea. The next thing is development from MIT CSAIL together with Inkbit, and it's something that has broader implications. What they've essentially done is they've looked at packing, and they've concluded that usually the packing density of any kind of 3D print is around 20%. Right. So they've developed something called a dense interlocking-free and scalable spectral packaging, and they're called SSP, which is a packaging methodology, kind of an algorithm that defines and then develops, where things can be packed, and it's basically a better packing algorithm. And you can see a result or a mock-up, I guess, in front of you. And the idea is that what they say they can do is they can go up to their algorithm, they can develop a packing density of 40%. So the packing increases considerably. Now, this has huge implications if they can do this correctly and if the prints work, right? And we have to realize, of course, that a lot of printing technology, we have a certain space we need to keep between the parts. So maybe then it doesn't work, and we would need to tweak this algorithm to take into account the minimum amount of space in between parts. And some other technologies, it's a little bit more complicated than that, so the algorithm would be more complex still. But imagine that this works. This has great implication because it means you can print more things in a build, right? You can lower the cost of parts, but your ROI on your machine is much higher. You could reduce the cost of parts and take on more assignments. I think this is absolutely wonderful. I think it's a really nice piece of IP to have as well. It's a really, really good kind of thing to have. So I think it's a great development. Anyway, so this is the news for today. My name is Joris Peels, and this was another edition of